So can I have a show of hands who requires help for part 2? Part 2, okay. So QT, we've got a... I need to recognize that these are similar triangles. Do you know why they are similar? Why? How do we test that triangles are similar? There are 3 tests that we can use. Okay, SAS, where we have the ratio of the corresponding sides plus the included angle that are the same. Okay, so that's SAS. SSS, what does SSS stand for? Side. In the case of similarity, what exactly are we testing? Is it the sides are the same? Ratio of the sides are the same, okay. And the last one? No, not ASA. For similarity, we've got SSS, SAS, and? Huh? No, not SAS. We already said that SAS already. Not RHS is for congruency. ASA is also for congruency. Huh? AA? A. Okay, so all 3 pairs of corresponding angles are the same. In this case, do I have anything that allows me to prove that these 2 triangles are similar? For similarity, right, we always like to go with the angles first. As far as possible, we try AAA similarity test. So are there any angles that are the same? Which angles are the same for these 2 triangles? Q. Wait, one by one, please. Too many letters already. Okay, come, let's have the first one. PTO. Where is P? T, O? Are you sure O? Or do you mean Q? Okay, PTQ as well as? RTS. Okay, these are vertically opposite angles, so they are the same. What else are the same? And the reason why? PQR. Okay, this angle with TRS. What is the reason that they are the same? Alternate angles. Then what's the next part? Parallel lines. Where are the parallel lines? PQ and RS. How do you know they are parallel? How do you know they are in the same direction? Huh? Where? Oh, RS equals to 2PQ. Okay, so this tells us that RS is parallel to PQ. Okay, so yes, we can use that. Now we have 2 angles that are the same already. Is it enough to prove that these 2 triangles are similar? Yes or no? Enough? Because we said we need 3 angles to be the same, right? So 2 enough or not? Why yes? How come I don't need to prove the third one? Okay, so the green one must be the same. Now if I don't want to use angle sum of triangle, what else can I use for the green color angles? No. Again, alternate angles, parallel lines, okay? So since these 2 triangles are similar, then do you know the ratio of sides? Do you know the ratio of sides? 1 is 2? 2, okay, because it is 1 RS equals to 2 PQ, right? So 1 RS, where is the RS? Okay, this part is RS. It is supposed to be 2 times of PQ. So I put a 1 over here, I put a 2 over here. Does that make sense to you? Okay, besides this pair of corresponding sides, what else has the ratio 1 is to 2? Which side to which side also 1 is to 2? Which side? TS and PT. Okay, which is 1, which is 2? Okay, this side is 1, this side will be 2. What else? Okay? Now this is correct. So now I need to do part 2. Find the value of T. I would like to make an equation. I would like to form an equation which involves the coordinates T4 as well as whatever information we found in part C, part 1. Identify QT in the yellow color highlighter part. QT, that's 1 unit, right? What about QR? How many units? QT is 1 unit. QR will be 3. Can you see why it is 3? Sophia? Can, right? 1:3, right? So QT is actually 1/3 of QR. Right? Just by chopping it into 3 equal parts. Okay, Sophia? Alright. Now, QT, I know that it is going to have this unknown over here, which is 10 plus t and negative 8. So let me just copy it down. 10 plus t negative 8. This is supposed to be equal to 1/3 of QR. Okay. Now, I need to write down the vector for QR. What is the vector for QR? Do we have the answer already for QR, or do we need to work it out? Do we have the answer for QR, or do we have to work it out? What is the answer? Where? No, we are supposed to make use of the coordinates to get the vector QR. QR. Do the intermediate step one, intermediate point. Okay, so what is the intermediate point that you would like for QR? From Q to R. What is the intermediate point that you would like to use? O? Do you say O? Origin. How about that? We use origin. So the origin is over here. We go from Q to O, then O to R. Okay? So that is our approach. QO plus OR, which is actually 1/3. What is QO? 10, negative 12. All okay with this 10, negative 12? Sophia, okay? Okay, do you know what is QO? From Q to O, right? How is it related to OQ? QO has a relationship with OQ. What is the relationship? Are they the same? Then how are they different? Put a negative sign, right? So if OQ is equal to negative 10, 12, which you agree with this? Okay, then QO must therefore be negative 10, 12, which is 10, negative 12. Can? Okay, so this is QO. Then I need to add OR. How much is OR? R will be negative 4, negative 12. Can? Now I have my equation already. Apparently, this is going to give me 1/3. 10 minus 4 is 6. Negative 12 minus 12 is negative 24. So this is actually 2, negative 8. And this is supposed to be equal to this. These two are supposed to be the same, right? They are both QTs. So what does this tell you about the value of T? How must T be? T must be negative what? 8. You can tell just by looking at the equation. Or if you want to work it out, it will be 10 plus T equals to 2. T equals to negative 8. Times 1/3 times 6 to get 2. 1/3 times negative 24 to get negative 8. So this is the answer for T, negative 8. Then you look back at your question, does it make sense? Yeah, this is T. If this is negative 8, then this being negative 4, this being negative 15. Yeah, negative 8 is between negative 4 and negative 15. So it makes sense. Alright? So now part D. Find the ratio. Area PQT over RST. PQT RST. You can just look at, instead of this yellow line, look at this green one. Now he's going to divide it into 3 equal parts. So PT is 1 part, TS is 2 parts. So that whole green color line is made of 21 units. Divided by 3 parts, you get 7 units. 7 units added to negative 15 gives you negative 8. That's the answer for T. Okay? So different methods you can employ to get the same answer. Now part D, ratio of the area, PQT RST. PQT RST. Right, so how do we do it? It is if I have a square, this is 1 unit. Then I have a bigger square, but this is 2 units. What is the ratio of area? 1 is 2? 2? Are you sure 1 is to 2? Now is it clearer? What is the ratio of the area? 1 is to? 4. Hey, why not 1 is to 2? Yeah, because it's the area. We can see very clearly that the ratio of the area is not the same as ratio of side, right? What is the relationship again? For similar figures, ratio of area is square. Is it a square? Let's try with another example. Let's try with side 3. What is the ratio of area for this to this? 1 is to 9. How do you get 9? 3 times 3. So the ratio is actually the square of the ratio of sides. Get it? So this is a recap. We learned this before. Now, these two triangles, we've proven that they are similar. Can you now tell me what is the ratio of area? 1 is to 4. Oops. So for this, I can remove everything already. The ratio is actually 1 is to 4. Because the ratio of sides is 1 is to 2. Squared. Alright? So I think the last lesson we talked about ratio of area of triangle, but for this type of triangle. So let's say this is 1, this one is 2. What is the ratio of the smaller triangle, okay, of yellow triangle to green triangle? What's the ratio of area? 1 is to 4. Why 1 is to 4? What did we just talk about last lesson? Ratio of area. Are they similar triangle? Similar or not? Obviously not, right? So can I use the square of ratio of sides for ratio of area? Cannot. Then what other tricks do I have? This being the perpendicular height. What is the area of the yellow triangle? Half times 1 times h. What is the area of the green triangle? Half times 2 times h. So what is the ratio of the side area? So now half times 1 times h. This one is half times 2 times h. What is the ratio? Yellow to green? Yellow to green? 1 is to 2. Can you see it? Can you see the ratio? 1 is to 2? Because when we put it this way, half and half cancel. H and H cancel. 1 is to 2 lah. So this is for triangles that are not similar. What if today I tell you that this is instead 3? So what is the ratio of yellow to green? Yellow to green, what is the ratio? Area. I don't think everybody is convinced. Are you all convinced? If you are convinced, you should be able to tell me the answer. 1 is to 3. Yellow to green, 1 is to 3. Okay, what about now? Yellow to green. Jolene, okay or not? You look very lost. Hoi, okay? Do you know the ratio of the area? Yes or no, Hoi? Okay, no. Don't worry, it's okay. We start off with 1 and 2. Let's label it as A, B, C, and D. I want the area A, B, C over area A, C, D. Yellow to green, right? Agree so far, Hoi? Okay, so area will be half times 1 which is BC times H, divided by half times 2 times H. Agree? Okay, then now we are ready to cancel, leaving us with 1 over 2. So the ratio of area, so area ABC to area ACD must therefore be 1:2. Can? Celine, okay? Now I will change the values again. Instead of 1 and 2, the ratio is now 2 and, for example, 5. So what is the ratio of area again? What's the ratio of area? 2 over here, 5 over here. Answer is 2 over 5. So this must be 2:5. Alright? This is for non-similar triangles. Now I want area of ABC divided by area of ABD. Okay, what is the ratio? 2 over 7, so 2:7. Understand? Any questions? You must be able to do this instantly. So this is for triangles that are not similar. For triangles that are similar, for example, like this. Do you agree that these two, the small triangle and the big triangle, they are similar? Why are they similar? A, B, C, D, and E. Why is triangle ABE similar to ACD? Which angles are you comparing? A? Wait, A what? CAD. Okay, this angle and CAD and which angle are the same? Huh?
No. Only one angle is
CAD is the same as
BAE.
BAE. Okay, it is the common angle, right? So one angle is the same already. I need another one angle. Which angle is the same? ABE and ACD. What is the reason? Corresponding angles, parallel lines. I remember I told you this before, just a while ago. And I even said that since Sec 1, you've been talking about these reasons. Right? You must remember it. Okay, so these two are similar. Then now I will give you the ratio of the sides. Let's say this is 1 and this is 2. What is the ratio of ABE over ACD? What's the ratio of the area? Sophia says 1:4. So what's the answer? Jolene, what do you think? 1:4 again. Xin-Hui, what do you think? 1:4 also. Muzdalifah? I'm talking about area lah.
It's similar, right?
Yes, they are. I just proved that they are similar, right? Muzdalifah, what's your answer? Also 1:4. Okay, you're right. The ratio of area is 1:4 because they are similar. Okay. Shufi, do you have questions? Now I'm going to change this to 2 and 3. What is the answer?
4:9.
Good. I'm going to change the question now. Instead of ACD, it's going to be BEDC. What is the ratio of area? Hey, look at what asking for BEDC. Answer. Answer. You think it's 4:5. What the rest think? Not sure, then you must think. Junior, what do you think is 4:5? 9 minus 4. So you mean this is 4 and this is 9 minus 4. Is that it? Do you all agree? Does his working make sense? Where did he get a 9 from? 9 is for which triangle? ACD, yes. 9 minus 4, you get 5. So this must be 5. So 4:5. Okay? Let's try a few more. This is 2 and 7. 2:7. What is the ratio of area ABE to, again, BEDC? What's the ratio of area? Four is to? What's the number here? All agree? Yes, it is correct. So this is what we do for similar triangles like this. Change question. This style of triangle. These two being parallel. A, B, C, D, E. What is the corresponding side to AB? What is the corresponding side to AB? ED or DE? ED or DE? How do we decide? How do you decide? Okay, let's find the angles that are the same one. These two are the same, right? But they got the opposite. What about this one? B and which angle? E or D? E, right? What is the reason? What is the reason? No more corresponding. Alternate angles, parallel lines. What about this one? Alternate angles, parallel lines again. Okay, so now I'm going to write down the triangle, the small triangle. Let's call it A, B, C. Is similar to triangle. Okay, your turn. What is it similar to? A, B, C, similar to? How do you decide? Okay, which is the first angle? D. All agree? Or anybody not sure? You were tested earlier this year, right? So I show you how you can draw the triangle using the corresponding angles. With this diagram, it makes it easier because 3 stroke. That is for A, and that's for D. So we start with D. What is the next one? E and C. So what is the corresponding side to AB? What is the answer? Is it DE or ED? DE. Now you should be able to tell me that it is DE. Okay? Then let's say this is 1 and this is 3. What is the ratio of area ABC over CED? Ratio of area again. What is it? 1:9? Correct. Because similar triangles, ma. What about AB? No, let's change it. AC over CD. What is it? AC over CD. 1:3. Because these are sides. Okay, maybe one last question. A, B, C, D, E, and F. Let's have this as 2 and this as 3. What is the ratio of area? Oh, this is a parallelogram. What is the ratio of area AEF over EDC? Ratio of area. Are they similar? You should be asking a question. Are they similar? So are they similar? Those two triangles? Okay, you must know why and how to prove it. Yeah, okay, alternate angles, you're right. So what is the ratio of the areas? Nine over 4? Okay, good. What about ECD over DAB? Huh?
Oh, 3 plus 2, 5, 6.
Answer. Come on. Good. Then what about ECD over ABCE? Get it? Why 21? Hurry, why 21? 25 minus 4. So actually what we can do when we see this type of question, right? Once I know the ratio of the sides already, I'll write down this is 4 units, this must be 9, then this must be 21. Can be instantaneous one. So if I ask you, what is the ratio of, last one, probably the last one already, AFE over ABCE. Okay, what's the answer? 9 over 21. Alright? You must be able to look out for triangles that look like this. They are similar. You must look out for triangles that look like this. They are also similar. So in this case, I have both. Okay? As well as combined in one question. So done for this one. So 6.3 is done. Like I said, we will finish up 6.4 today, which means the syllabus will be completed today. So let's begin. Applications of vectors in geometry. So parallelogram, opposite sides must be same in magnitude, they must be parallel, so the vectors must be the same. If we go from the same, if we go in the same direction. So AB is equals to DC. Likewise, BC is equals to AD. Okay, all this we know already lah. Show that AD equals to BC. In example 24, it is very tempting to look at the question, it's a quadrilateral, then show that AD equals to BC. Yeah, I know that AD is equals to BC, but then how to prove it? I mean, it looks like it, right? Then we see that it is a quadrilateral. They did not say it is a parallelogram, but they did tell us that AB is equals to DC. AB is given over here, this part is equal to this part. So now I want the vector AD. I need to break down my vector AD. Okay, so what they have done, AD is equals to AC plus CD. Okay, alright. AC plus CD. Then let me write out AC plus CD. A to C, then C to D. We start at A, we start at A. We end at D, we end at D. Whatever is intermediate, doesn't matter. Okay? So we can rewrite this AC plus CD to become AC minus DC. You all know how to flip. Now, DC is actually the same as AB. So we're going to substitute them this way. And then AB is actually negative AB is the same as BA. So AC plus BA is the same as AD so far. Okay, so far until this step everything is correct. Then I've got a vector plus another vector with the same intermediate point, A and A. I can switch them around. AC plus BA is the same as BA plus AC. Vector A plus B is the same as B plus A. Can switch them around, right? So now I put an A in the middle. Now my starting is B and my ending is C. With this, we have proven that AD is the same as BC. What this means when we are drawing it out is that as long as you draw two parallel lines, and these two parallel lines, they have the same distance. Let's say over here and over here. Two parallel lines, they have the same distance. This must be a parallelogram. So A, B, C, D. These two must be the same vector. Okay? This is the summary, the application of it. So justify that it is a parallelogram. We say that since these two vectors are the same, then they are parallel. Then since the other two vectors are the same, then they are also parallel. So two pairs of parallel lines must give you a parallelogram. So that is the proof. So your turn to try. Try it 24. Keyword over here, bisect, which means cut into two equal parts. We start with AB. I want to rewrite it in terms of something that is given. That is point E. AE to EB. So AE over here, I want to replace it with something else. Anything. Anything that can be replaced by. What will it be? EC. Yes, the order matters. Because they are on the same line. It is a diagonal. And it is cut into two equal parts. So AE must be equal to EC. These two vectors are the same. I'm going to do the same for EB. E to B over here. What is equivalent to this vector? DE. They are equivalent. Now, I can switch them around. DE plus EC. So I get DC. Direction? Direction matters in vectors. Did my step show any part that direction does not matter? AE equals to EC, yes? Okay, so your question is AE equals to CE, is it? So what do you think? Are they equal? It's equal but the direction not equal. AE is a vector from A to E. CE is also a vector, but in the opposite direction. Can you say that they are the same? Huh? Don't scare me. How can vectors be the same when they are in opposite direction? Can vectors be the same but they are in opposite direction? No, cannot. But Junior is very confused about something. Can anybody guess what's going through his mind? I know what's going through your mind. Can anybody guess what's going through his mind? Why does he feel that AE is CE? And yet, Mr. Wong said they are different. Yeah, I know they are different direction, but what is he confused about? Can you all guess? Magnitude. How do you say magnitude? Are you confused about magnitude? Are you talking about magnitude? Then what are you talking about? So you mean, is this now equal, is it? Uh-huh. No need to put negative. Why must put negative? AE, look carefully. AE from here, bottom left to top right. Right? That's AE. I want an equivalent vector. Definitely it must be on the same line. It must be on the same line, right? So that they are parallel. They must have the same magnitude. So I know it is going to be between 2 points, E and C. Now your decision is whether it starts from E, ends at C, or it starts at C, ends at E. Correct? Okay. Looking at the first vector, AE starts from the bottom left. We go to the right, then we move upwards. For an equivalent vector, you also must go to the right, then you must move upwards. That is how we can say that they are in the same direction. Agree? Therefore, which point must come first, E or C? In order for you to move to the right, then move up. Which one must come first? Yeah lah, D lah. What was this? E. E must come first. E must come first, then you go up to C. Okay? So you're not confused over magnitude. I thought you were confused over magnitude. Okay, so this is our answer for part A. Then justify that it is a parallelogram. How do you justify it's a parallelogram? I would like you to copy this down. Since what do we have? AB equals to DC. Since these two vectors are equal, then AB parallel to DC. Then we can do the same to prove the next line, that is AD is equals to BC. So AD parallel to BC. You need to do the same working to prove that these two vectors are the same. Okay, then since the quadrilateral has two pairs of parallel sides, then ABCD is a parallelogram. So PQ, from P to Q, most of you start off with P to B, then B to Q. That's good. Now we need to make use of this information. These points are the midpoints of the quadrilateral. So instead of writing PB, I want to rewrite it such that in the end, I will be able to relate it to AC. So PB is actually half of AB. Because it's the midpoint. So PB is half of AB. Then BQ is half of BC. Why cannot use half? I'm using the half because of the information that it is the midpoint. I'm not using this particular one. Okay. So this is what we have. Now, half of AB plus half of BC. Can factorize out half, right? AB plus BC. What is AB plus BC? AC. Don't even need to look at the diagram because I see that the B and the B are intermediate points. So this must be half of AC. So PQ is half of AC. From here, whenever you see something like this, a vector equals to another vector with a scalar in front. Two things you need to conclude. First, PQ parallel AC. Always, standard one. Second thing, that is irrelevant. Oh, okay. Actually, it's relevant to this question. The second thing is that magnitude of PQ equals to half of the magnitude of AC. These are the two standard things you must always be able to write when you see this. Okay, will be tested in O levels. So from here, magnitude of a vector, it is actually written as PQ equals to half AC. Now, this over here, this format, PQ equals to half AC without the arrows, tells you that they are talking about scalar. Before we learn vectors, when you see this diagram, when this diagram is given to you, and we tell you PQ, okay, before you learn vectors, I tell you PQ, your understanding is just this line, right? You do not care about direction. You are only caring about magnitude. Am I right? Now that we have learned vectors, when I put an arrow on top, it means I start from P, I end at Q. Then when I put in these two lines, it means magnitude. So what we've learned in the past doesn't change. When I just simply write PQ without a vector, without arrow on top, it is a scalar and I am talking about the magnitude. So if you do not like to write things like this, you can write this. Get it? It corresponds to whatever we have learned since primary school. Labeling. Every time I call a line segment AB, I'm talking about the length. So that's all for today's lesson. You try, no, not this one. Read this and do this.